Okay guys, so Lab 10 is all about standardization of an acid-base reaction, titrations, etc. So the first part that I want to do is I want to tell you guys what standardization means, because a lot of you had a little bit of a problem with that. So let's think of an analogy. If we have this rock and we have no idea how much it weighs, we can put it on a scale, and we can put this guy on here which weighs 1 pound, then we can put a second one, and if we put a third one and the scale suddenly balances out, what is that telling us? That tells us that this rock now weighs 3 pounds, right? So once you know how much the rock weighs, you can compare the rock to any other object that you want. So let's say now we want to compare it to a car. So now we're comparing this 3-pound rock to a car. And, well, this throws off the scale. So what if we now need 2 rocks, 3 rocks that are, of course, exactly the same as that first rock? So this tells us that the rock now weighs 3 pounds. So we've standardized the rock. So now we can find the unknown weight of the car, which is going to be 9 pounds, because we've got 3 3-pound rocks. So the whole idea of this lab was to standardize some sort of unknown substance. In this case, we used an acid over here. We knew the concentration of this acid, so we used that to titrate. And all titration means is to just kind of work them until you reach whatever goal you're trying to reach, or to mix them until you reach this goal. So we mixed an acid of known concentration with a base of unknown concentration. So I'm just going to label that as base. And then we used that base that had now been standardized. So that's where everyone kind of got mixed up, is this base is your now standardized base. And that just means that you now know how much it weighs, so you now have now you can use it as a standard to find the acidity or the concentration of this unknown acid. So let's quickly walk through that again. So we've got right here, we've got a nice little equation that basically tells us what we have to do. So we've got this. Basically, we've got this acid of known concentration, which is going to be, we're going to weigh out this KHP. And so we weigh out our KHP, so some sort of, let's clear that. So some sort of grams of KHP. Now, grams is not a useful measurement in chemistry, so we need to convert that into moles. So luckily, we know that there are 204.2 grams in 1 mole of this acid. So we can use that knowledge then to find out how many moles we have. So this grams will obviously cancel out with this other grams, and we will get whatever quantity moles of acid. So this is, I'll just put a squiggly for our number, moles of acid. So that tells us how many moles of acid we've got. So now we know that 1 mole of acid plus 1 mole of base gives us our neutralized solution of water. So basically, this is a 1-to-1 ratio, right? So for each 1 acid that we need 1 base as well. So we then go ahead and take that 1 mole of acid and multiply it by the ratio of base to acid. So we've got whatever moles of acid all over 1. Everything's always over 1. So we multiply that by the moles of acid. So 1 mole of acid needed per 1 mole of base. And the reason I put acid on bottom is so that we can cancel out this mole of acid with this mole of acid, and we're still going to have the same quantity because we're just multiplying by 1. And then the final step is we need to change from moles. So now we have how many moles of base we need, well, what's the concentration of our liquid? So we need to then multiply by whatever our concentration is. So we're going to need moles on bottom and liters on top. And let's say we have a 0.2 molar solution. So that means that there are 0.2 moles for each 1 liter. And that will allow the moles to cancel out, and we will be left with how many liters of our base we need. So we need liters of hydroxide. So whatever quantity that is, liters of hydroxide. And that's how you find how many in this case, I'm sorry, they found the molarity of their sodium hydroxide solution. So I guess the first step was to standardize it. It's the same thing, except now we instead of putting moles, we put how many liters of our solution we needed. Sorry about that. Okay, so we need to change this back because it's not going to cancel out anymore. So this is still moles of base, and now we need to know how much did we add. Well, we added, let's say we added 22 milliliters. Don't forget to then convert this to liters, so we would just go 0.022 and take off this m. So that's how many liters we used, and this will give us the concentration of our now standardized solution. So whatever it was before divided by 0.022, and that will be in units of, well, we've got our moles right here and we've got our liters right here, so our units are going to be in moles per liter. Alright, so that would be how you would standardize your concentration. Then it goes through another calculation down here on how to then find the quantity of, or the concentration of the hydrochloric acid. So that is on page 71, or yeah, page 71. So go through these calculations, make sure you understand how to do them. If you just use the units, if you just use moles and moles of sodium hydroxide and moles of hydrochloric and liters of hydroxide and stuff, you should be able to solve pretty much any of these titration problems without an issue. So then that will take us to Lab 12. Oh, and by the way, the practice problems are really helpful on all of these. So that takes us to Lab 12, where we need